Hey everyone, welcome to Homeschool and welcome back to Class 11 Chemistry, the chapter Hydrocarbons. We have completed everything about alkanes and alkenes, and today we will try to complete all about alkynes. So in my today's class, I'm going to cover the preparations, the isomerism with respect to alkynes and also the chemical properties of alkynes. So let's quickly start the topic alkynes. Fine. So as the name suggests, alkynes are unsaturated hydrocarbons which have carbon-carbon triple bond, isn't it? And the carbons which have got a triple bond will have the hybridization, sp hybridization. So all this we have discussed in our introductory class of this chapter, isn't it? So since these carbons have sp hybridization, these carbon atoms are more reactive. That means they are more electronegative. So I can say that compared to alkenes and alkanes, alkynes are very, very reactive hydrocarbons, I can say. Because of their hybridization, that is sp hybridization, they do have. Clear? Fine. And coming to general formula of alkynes. See, general formula of alkynes is CnH2n minus 2, right? Fine. The very first member of alkyne is acetylene. So we write a formula CH triple bond CH. So this is the first member of alkyne. If you have to name this according to IUPAC rules, we will call this as ethyne, isn't it? So commonly it can also be called with the name acetylene. So you should remember the common name here, that is acetylene, which is nothing but the first member of alkyne. Okay, so we have discussed the hybridization of carbons, right? And also about the first member. And coming to the triple bond that is there between carbon and carbon. In this triple bond, you will always observe 2 pi bonds and 1 sigma bond. Okay, so 2 pi bonds have formed by overlapping of unhybridized p orbitals. Okay, sigma bond is formed by hybrid sp orbital. Yes or no? So sp hybrid orbital overlap, end on end overlapping. Okay, so this leads to the formation of sigma bond, and 2 unhybridized orbitals you will have on both carbons. So they will overlap sideways, and that leads to the formation of pi bond. So all that we have discussed in our chemical bonding chapter in a very detailed way in a video, hybridization, right? So if you have not yet watched, video links are provided in the description. You can go and watch it out. Fine. So just try to remember this particular aspect. This is important. Clear? Fine. And now let's go for the isomerism that alkynes can show. Alkynes can show 3 different structural isomerism. Okay, they can show chain isomerism. They can show chain isomerism. Right? And they can also show position isomerism. Position isomerism. See, suppose you have CH3, C triple bond C CH3. This is one molecule, and I also have CH triple bond C, CH2 and CH3, right? See, what is the molecular formula of this compound? You have 4 carbon atoms and how many hydrogen atoms? Altogether 6 hydrogen atoms. Even this particular compound also has 4 carbon atom and 6 hydrogen atom. Molecular formula is same, but where do you find the difference? Difference you will find in the position of triple bond. In this compound, the triple bond is at carbon 1, whereas here the triple bond is at carbon 2, isn't it? So they both become positional isomers. If the chain length is different, it is called as chain isomers. But if the position of double bond is different, then it is called as positional isomerism. Coming to the third type of isomerism that alkynes show, that is functional group isomerism. Functional group isomerism. Okay. See, usually alkynes and dienes become functional group isomerism. Suppose I take a alkyne this CH triple bond C, CH and CH3, and I'll take a alkadiene something like this CH2 double bond C, H, CH double bond CH2. So which alkadiene it is? Alkadiene in the sense two double bonds you have. This is called buta-1,3-diene, isn't it? And this is 1-butyl. And if you have to check this molecular formula, you can check it out. See, you have got 4 carbon atoms and how many hydrogen atoms? 3 plus 1, 4 and 5, isn't it? Hydrogen atoms are 5. Whereas here also, you have 4 carbon atoms and see the hydrogen atoms 2 plus 1, 3, 4, 5, 6. Isn't it? Sorry, here I forgot to put 2. So here also you will get C4H6, right? So both of them have same molecular formula. But what is the difference in these two compounds? The functional group itself is different. So here you have a triple bond, but here you have double bond, isn't it? So such isomers are called functional group isomers. So alkynes are functional group isomers with dienes. Alkynes also show position isomers and alkynes also show chain isomers. Okay, and mainly alkynes show ring chain isomerism. Okay, so they will also show ring chain isomerism. Okay, suppose I take the example something like this CH3C triple bond CH. And you look at this compound, okay, cyclopropene, it is cyclopropene, right? And this is, what is that? Propyne. So both of them, they have same molecular formula, but definitely one is a chain and the other one is a ring, right? So these are called ring chain isomers. So alkynes show ring chain isomerism, they show position isomerism, and they also show functional group isomerism. So they are functional group isomers with dienes. Clear? So this is all about isomerism of alkynes. Now let us understand all the preparatory methods of alkynes in a very detailed way. See here, first and foremost, let's talk about laboratory method of preparation. So under preparations of alkynes, I am talking about laboratory method. Okay, so very important laboratory method. So in lab, alkynes can be prepared from calcium carbide. It can be prepared from calcium carbide. So how do you write the formula of a calcium carbide? It is CaC2. So first you will have to understand how to make this calcium carbide. First we will try to make calcium carbide and then from calcium carbide we will try to prepare acetylene, that is ethine. Okay, so whatever the preparation methods I am showing you, all of them include the preparations of ethine. Very important reactions. So you must pay the concentration here. Clear? Fine. So let's try to prepare calcium carbide first. So we take a raw material calcium carbonate. So we know this is limestone, right? Calcium carbonate. And this on heating we get calcium oxide plus carbon dioxide. And we know this is called with a common name quicklime, isn't it? So now this quicklime, that is calcium oxide, when heated with carbon, okay, you will get calcium carbide plus carbon monoxide gas. Okay, so this is how you are going to get calcium carbide. So when quicklime is heated with coke, that is carbon, you will get calcium carbide. And now this calcium carbide on hydrolysis. So what do you mean by hydrolysis? Addition of water. We break water first and then we add to a substrate, isn't it? The reactant. That is called as hydrolysis. So on hydrolysis, you will get calcium hydroxide plus C2H2. Okay, so just suppose this is a positive part here and this is a negative part. And which is a positive part here? H plus is a positive part. And which is a negative part of water? OH minus. Positive part here is calcium. This is combining with negative part of water. So if calcium combines with OH, definitely you will get calcium hydroxide. And which is a negative part here? Carbon. Which is a positive part of water? Hydrogen. So carbon combines with hydrogen. And what do you get? C2H2. C2H2 is nothing but what? Acetylene. That is ethine, isn't it? So this is one of the very, very important preparatory method of alkyne. Fine. And now, in our second method, let's prepare it from iodoform. Okay. So reaction of iodoform. This is very, very important for competitive examinations, guys. So reaction of iodoform with silver. Okay, very easy reaction. So iodoform, how do you write iodoform? CHI3 is iodoform, right? So you can prepare it from any haloform actually. It's not necessarily iodoform. You can prepare from any haloform reaction here. So what do you mean by haloform? Haloform can be chloroform, that is CHCl3. It can be bromoform, that is CHBr3. And it can also be iodoform, that is CHI3. So all of this you can use for this reaction. So I have taken iodoform here, that's it. Clear? So when this CHI3 is heated with silver, and here we will have to take 2 molecules of iodoform. The other molecule, let me write it here just for convenience sake. Okay. So this is one molecule of iodoform. This is another molecule of iodoform. See the iodine, that is I3 from this molecule and I3 from this molecule comes out with Ag. So what is left out here? What is left out? Left out is CH. This part is left out and here this part is left out. Isn't it? Join both of them, CH and CH. How do you join? You join it with a triple bond. So you got your acetylene. Plus what is a byproduct that you get here? Byproduct is AgI. How many molecules of AgI? See, 3 iodines here, 3 iodines here. So altogether 6. So that 6 Ags are actually combining with 2 molecules of iodoform, or for that matter any haloform. Okay, so in the place of iodoform you can also have chloroform and you can also have bromoform. Same way reaction takes place. So this is one of the very, very important reaction for competitive examination. Questions have been asked on this. Clear? Fine. Coming to another important preparation of alkyne, that is from third preparation. It is from vicinal dihalides. Vicinal dihalides. So in my previous videos I told about vicinal dihalides and geminal dihalides, isn't it? So vicinal dihalides, in the sense, in a molecule you have 2 halogens. Dihalides, name only will tell you, you have 2 halogen atoms. And where they are present? They are present on adjacent carbon atoms, side to side carbon atoms. Vicinal means what? Adjacent. Clear? So let's take one example for vicinal dihalide. Let me take CH2Br, CH2Br. So this is the best example for vicinal dihalide. See, two halogen atoms are there where they are attached to the adjacent carbon atoms. Okay, so this is the best example of vicinal dihalide. And this vicinal dihalide, when I treat it with alcoholic KOH, alcoholic KOH is a base. Whenever alcoholic KOH is there and you have alkyl halides, definitely you will observe a reaction called dehydrohalogenation. So what do you mean by dehydrohalogenation? One bromine, that is one halogen and one hydrogen, will get removed from the substrate. That is called dehydrohalogenation. So now let's remove one bromine and one hydrogen. Suppose if I remove this bromine, which is the hydrogen that I can touch? I cannot touch these hydrogens. So I'll have to remove one of these two hydrogens. So I have removed this Br and this hydrogen. So HBr as the byproduct you will get outside. So what is remaining here? If I remove one hydrogen here, what is remaining? CH. And this Br is as it is. Whereas CH2. But you know, valency of these carbons is not satisfied. So I should definitely put one double bond there. Okay, now I will do second step of dehydrohalogenation. One more step I will conduct the same reaction again. But here, okay, I can use another base which we will call it as sodamide. Sodamide. Sodamide is also strong base, that is NaNH2 in ammonia. Okay, sodamide is nothing but NaNH2. So sodamide in ammonia, when used, you know, it can become a really strong base. So in presence of this base, again the same step. One Br, one hydrogen is removed. So which Br I can remove? This is the only Br available. Which is the hydrogen that I can remove? I cannot touch these hydrogen. I'll have to remove one of those hydrogens. Okay, so if I remove this Br and one of this hydrogen, what is remaining? You have CH double bond CH, but you see the valency of carbon atoms, it's not satisfied. So I'll put a triple bond. So what is this? You got your acetylene, right? You got your ethyne molecule. So this is how from vicinal dihalides you can prepare acetylene, right? So these are some of the major and important preparation methods of alkynes. And now let's talk about the chemical properties or the chemical reactions one by one. See, coming to chemical properties, the very first reaction that you have to be very careful and very important is acidic nature of alkynes. So the first chemical property is acidic nature of alkynes. So alkynes have acidic hydrogen. If I take CH triple bond CH, you know, these carbons have sp hybridization, like I have already discussed about this, right? So sp hybridized carbons are more electronegative, we know, and the hydrogens which are there with sp hybridized carbon is always more acidic, right? So more acidic. Remember, not all hydrogens. The hydrogens which are directly attached to sp hybridized carbons are more acidic. So that makes the alkynes to have that acidic nature. Because they are acidic in nature, they can easily react with metals like sodium, and bases. They can easily react with bases like sodamide, that is NaNH2. Okay, so we all know any acid easily reacts with metal. On reacting with the metal, what do you expect? Yes, definitely salt and hydrogen gas, right? So any acid, we know this is a very common reaction, right? Acid whenever reacts with metal, we always get that respective salt plus hydrogen gas. So the same reactions we are going to write for different alkynes. Okay, so always remember guys, which hydrogens are more acidic? It is those hydrogens that are connected to sp hybridized carbon only. So these hydrogens on reacting with a metal, the hydrogen gets displaced by metal, right? Giving you salt and hydrogen gas. Let's see the examples now. See, suppose I have CH triple bond CH and I will treat this acetylene with sodium. So what are the compounds that I can get it here? So I should get salt and hydrogen because this is acidic and this is a metal, right? So I have taken one sodium. So what happens? One sodium will replace one acidic hydrogen. Actually, there are two acidic hydrogen. One is this, the other one is this. Since there is only one sodium, this metal will displace this hydrogen. That's what the metals always do, right? Whenever we treat it with acid, they will displace hydrogen that is present in an acid. So this metal is displacing this hydrogen. So what do you get? In the place of hydrogen, this sodium goes. So what is the product you get? CH triple bond CNA. Okay, plus hydrogen. So I write it as half H2 just to balance the equation. Clear? So this is the salt you will get. The name of this salt is called sodium. It can be called as sodium ethynide. Okay, so this is the salt you will get. And now again for this, I take the same salt that I got it there, CH triple bond CNA. Okay, I treat it with one more sodium. Definitely reaction happens because there is one more acidic hydrogen left out. Even you can replace this also, right? So when you treat it with second sodium atom, this hydrogen gets replaced and you will get CNA triple bond CNA plus half H2. So you call this as disodium ethynide. Disodium ethynide. Clear? Fine. So now suppose if I take CH3 C triple bond CH. So I took propine now. Okay. So if I treat it with sodium, what is the reaction that you can expect? How many replaceable hydrogen atoms are there here? Just one, guys. Okay. So you can only replace this hydrogen. There are three hydrogens here, but they are attached to sp3 hybridized carbon. You cannot remove these hydrogens. You can remove only the hydrogen that is connected to sp hybridized carbons. Only this carbon has hydrogen atom, whereas the central carbon which was having sp hybridization do not have any hydrogen. So you can only replace this hydrogen and you will get CH3 C triple bond CNA. Okay, so plus half H2. So what do you call this as? This you call it as sodium ethynide, right? This you will call it as sodium propionide. Clear? So this is how we will name this kind of salts. Suppose, one more question. If I have a alkyne, something like this, CH3, C triple bond, CH3. This one, if I treat it with sodium, can you tell me whether reaction takes place or not? Can you tell me whether we get salt here or not? Okay, so I'll just give you a clue. You all know that which hydrogens, if there, it can react with sodium, right? You should have hydrogen atoms at sp hybridized carbon. And now look over, which are sp hybridized carbon? This and this. You don't have any hydrogen to replace. So does it react with sodium? No, never. So there is no reaction in this case. There is no reaction. Clear? So this is how alkynes react with metals and bases, right? And actually these reactions can be used. You can use these reactions to distinguish between alkynes and alkenes. So actually both are unsaturated compounds. You know, most of the reactions are common for alkynes and alkenes, but not this reaction. This reaction is shown only by alkynes but not alkenes, isn't it? Because alkenes, whatever the hydrogens you have in alkenes, they are not acidic. Only alkyne hydrogens are acidic, right? Since they are acidic, they are reacting with sodium to give some salts. So these reactions are very, very specific only for alkynes but not for alkenes. So if you want to differentiate whether something is alkyne or alkene, you can always go for this reaction. Not only that, you can able to distinguish or identify. It helps to identify terminal alkynes. So what do you mean by terminal alkynes? If triple bond is present at last carbon atom or first carbon atom, it is called as terminal alkynes. You know, here ethyne is a terminal alkyne, and you know, propyne is a terminal alkyne because triple bond is there at you can see it is there at last carbon, right? Whereas you see this butane, 2-butene is not a terminal alkyne because triple bond is not there at last carbon. It is there somewhere in the middle. So this is not called as a terminal alkyne. Whereas if I have something like this, CH, triple bond C, CH2, CH3. What is this? 1-butene. This I can call it as a terminal alkyne because triple bond is there at the first carbon, right? So hope you are clear with the difference between terminal alkyne and non-terminal alkyne. This is a terminal alkyne, whereas 2-butene, where you don't have any acidic hydrogens actually. So they are non-terminal alkynes. You know, always terminal alkynes will give a positive test, you know, when it reacts with metals. Terminal alkynes only can react with metals, not non-terminal alkynes, isn't it? So that is what I meant to say. So you have two uses out of this reaction. One is it can be used to distinguish between alkynes and alkenes, and another one is it can be used to identify terminal alkynes. So you have, for competitive purpose, I'll give you two more equations which are very, very important. You know, CH3 triple bond CH. Okay, so I took a propyne. This propyne on treating with cuprous chloride. Okay, so when I use cuprous chloride, I get red color precipitate because copper will displace this hydrogen. I get a salt CHC triple bond CCU, which is red color salt. Okay, actually when you treat it with sodium, no, you will not have any color for the salt. So it's very difficult to identify when there is no formation of precipitate or when there is no colored substance formation. It's very difficult to say whether the reaction taking place or not. It's very difficult to identify whether something is alkyne or alkene using this particular reaction, that is with sodium, right? But reaction with cuprous chloride, okay, so copper replaces H. That means the so-called product will have red in color. If it is alkyne, it will react with cuprous chloride, otherwise no, right? So it's very important. Cuprous chloride on reaction with terminal alkynes, that means alkynes which have got a stick hydrogen, definitely the salt that is formed will have red color. So red color precipitate you will get. Okay, so one more, alkyne reacting with Tollen's reagent. So Tollen's reagent in the sense ammonical silver nitrate solution. Okay, so when terminal alkynes, that is CH3, C triple bond CH, when reacts with ammonical silver nitrate, you know, silver gets replaced here in the place of hydrogen, you will get CH3C triple bond CAG, and this is actually white PPT. Okay, so with cuprous chloride you get red PPT. Alkyne, that is terminal alkyne, you should have acidic hydrogen. So acidic hydrogen containing alkynes, when reacts with Tollens reagent, you get white precipitate. So usually these two reactions are best used for distinguishing between alkynes and alkenes, and also they are helpful to identify terminal alkynes because the products appear in the form of colored substances. Okay, so the moment you look at the color, you can see that yes, reaction happened. So when does the reaction can happen? If it is a terminal alkyne, if it is an alkyne, right? So this is how we can talk about the acidic nature of alkynes. And now we will go for another type of chemical property of alkyne, that is addition reactions. Coming to addition reactions, the first reaction that we talk about is addition of hydrogen. See, if compounds have double bond or triple bond, addition reactions are very common. Okay, since triple bond is there, addition reactions are very, very common. First, let us see how to add hydrogen. So the first reaction is addition of hydrogen. So it is just like the way you added hydrogen to alkenes. Say suppose I have CH triple bond CH, I am adding hydrogen. So here hydrogen addition is always done in the presence of catalysts like palladium, platinum or nickel. Okay, so it is called catalytic hydrogenation. Hydrogenation means addition of hydrogen in presence of catalyst is called catalytic hydrogenation. Fine. So one hydrogen atom is added to one carbon, the other hydrogen atom is added to another carbon. Triple bond will become double bond. So what is the product you will get? CH2 double bond CH2. Again for this fellow, if you add hydrogen again in the presence of catalyst, you will get CH3 single bond CH3. Okay, so always you can add here everything in two steps. So when you add initially to alkyne, you are getting some alkene variety, and again to that when you add hydrogen, you will get alkane. Okay, so this is how we do the addition reactions. So similarly, like the way you added hydrogen, you can also add halogens. So next, let's go for addition of halogens. So here, let me add Br2. Clear? So can you able to write the product on your own? CH triple bond CH. I add one molecule of Br2 initially. So I do get CHBr double bond CHBr, isn't it? So one Br is added to one carbon, the other Br is added to another carbon. And here this reaction takes place in presence of a solvent CCl4, carbon tetrachloride, right? And again on addition of one more molecule of Br2, you will get CH Br and one more bond with Br and another CH, two Brs on this carbon also, right? So what is the IUPAC name of this compound? Can you able to give its IUPAC name in the comment section? Yes, definitely. Post the answer about the IUPAC name of this compound in the comment box. Don't forget. So this is what we mean by addition of halogens. And here this reaction is used as a test for unsaturation, right? We have also seen it in case of alkene reactions. It is used as a test for unsaturation. So how this is used as a test for unsaturation? Bromine is reddish violet in color. When it reacts with alkyne this way, it loses its color because it's not at all a bromine now, it has converted into something else, right? So reddish brown color of bromine disappears when this reacts with alkyne or alkenes. That is why this reaction is used as a test for unsaturation. Okay, if you want to detect whether there is a presence of double bond or triple bond, you can always go for this reaction. So this is all about addition of halogens. And now let us talk about addition of hydrogen halides. Very, very important. Third addition reaction is addition of hydrogen halides. So what do you mean by hydrogen halides? It can be HBr, HCl, HBr, HCl, right? HI, all these are called hydrogen halides. So we have studied Marconi-Cauchy rule, right? So here alkene reactions are very, very important. If you are clearly well aware of alkene reactions, then all these are just easy. Okay, you just have to compare and study, that's all. Right? So there we studied a rule called Marconi-Cauchy rule. So here also we have to follow the same Marconi-Cauchy rule when you add HBr. Okay, so let me take an alkene propine. So let propine be CH3C triple bond CH. And for this, if I have to add HBr, do you remember what does the Marconi-Cauchy rule says? The positive part is always added to carbon having more number of hydrogen across a double bond or triple bond, right? And the negative part is always added to carbon having less number of hydrogen. So this is what we mean by Marconi-Cauchy rule. If you are not aware of this Marconi-Cauchy rule, please do watch my videos on chemical properties of alkene, so that you will get complete idea about Marconi-Cauchy rule. Okay. So what is the product you will get here? CH3C. For C, Br is added, right? Triple bond becomes double bond and this will become CH2, right? And I can do one more step of HBr addition here. So one more step I am following. Positive part is added to carbon having more number of hydrogen. Negative part is added to carbon having less number of hydrogen. So what is the final product you will get? CH3CBr, another Br to the same carbon. Now double bond becomes single bond because it's addition, and this fellow will become CH3. So you will get dihalides. And you look at here, this is not a vicinal dihalide. Both halogens are attached to same carbon. So this type of dihalide is called as geminal dihalide. Okay, so if two geminal dihalide, it means if two halogens are attached to same carbon, it is called geminal dihalide. Say if this was the case, CH2Br, CHBr, CH3. If this is the case, this is called vicinal dihalide because two halogens are there on adjacent carbon atoms. But here both halogens are there on same carbon. Then in that case, we call such compounds as geminal dihalides. Okay, so when you add hydrogen halides to alkyne, you will always get geminal dihalides. This is very, very important. Okay, so this is one addition reaction of alkyne. And let's talk about the last addition reaction of alkyne. That is fourth one, addition of water, which is very, very, very important. Addition of water. Okay, so addition of water always takes place in presence of mercuric salt, Hg plus 2 salt, and dilute sulfuric acid. Okay, water addition to alkyne always occurs in presence of mercuric salt and dilute sulfuric acid. Remember guys, this is the most important reaction you should never ever forget. Right? Okay, now let's see how. I'll take the same alkyne here, CH3C triple bond CH. Okay, and I will add water. So here also water, it has positive part H plus and it has got negative part OH minus. Follow Marconi-Cauchy rule because this is unsymmetrical alkyne, isn't it? So positive part is added to, so positive part is H plus, negative part is OH minus. Positive part is added to carbon having more number of hydrogen. Negative part is added to carbon having less number of hydrogen. We just followed Marconi-Gauss rule. So what is the product we get? CH3, C, and here what do you get? OH, and here triple bond becomes double bond, and this fellow CH will become CH2, right? And actually this is called enol. This is called enol. Whereas enol can be converted into keto form always. Here keto-enol tautomerism takes place. So what do you mean by keto-enol tautomerism? It is a conversion of enol to keto. Enol. En means double bond. See, double bond is there. All in the sense OH, alcoholic group. Double bond immediately if OH is there to that carbon. It is called enol. So this enol form will always gets converted into keto form. Observe this. How? There is a lone pair on hydrogen, right? Sorry, lone pair on oxygen. This lone pair will move here. This bond will move there. So what do you get? You get CH3, C, double bond OH, CH2 minus, right? And this minus will take up this hydrogen. So this fellow will become CH3. So this is what the ketone you will get. Okay, so this is the final product. So what is the product that you get when alkyne, that is propyne, is treated with water? You will get acetone. You will get acetone as a product. Okay, so enol form gets converted into keto form. This is what we mean by keto-enol tautomerism. Very, very important. Now let us check it out. If I add water to acetylene, what will happen? So now I am going to add water molecule to acetylene. Acetylene in the sense ethyne. This is also very important reaction. So ethyne is what? CH triple bond CH. So for this I am adding water. So when I add water, what do I get? Water has H plus and OH minus. So positive part is added to one carbon, negative part is added to one carbon. You cannot use any Marconi-Gauss rule here because it is a symmetrical alkene. Symmetrical alkyne, sorry. Okay. So what do you get? You get hydrogen, I added to this, OH, I added to that carbon. So CH, OH, and here you have a double bond, CH2. So again it is like a enol, right? So now this gets converted into keto form. That means there is a lone pair on oxygen that is shifted here and this bond is moved here. And where will this hydrogen go? Later it goes to this carbon, because this bond when shifted onto this carbon, you get a negative charge. So that negative charge takes up this hydrogen. So ultimately, what is the product you can write here? CH, C has a double bond O, and this will become hydrogen shifted to this carbon, so that will become CH3. So what is this? CH3, CHO, right? So acetaldehyde you will get. You will get acetaldehyde. So when ethyne is treated with water, final product is acetaldehyde. When propyne is treated with water, final product is acetone. Very, very important. Both reactions are very, very important, guys. You shouldn't forget them because they have asked many times in the competitive examinations. Okay, fine. And now I am going for the last reaction, that is polymerization. Polymerization. So especially I am going to discuss about cyclic polymerization. Cyclic polymerization. Polymerization in the sense what? When so many alkynes gets connected to one another, you get a long chain. That long chain is called as polymer. Okay, so now I am going to take only 3 alkynes, and what alkyne am I taking here is ethyne. Okay, so I am taking 3 ethynes. So let me just show this way. This is one ethyne. Okay, so this is another ethyne molecule, and this is the third ethyne molecule. So just why did I write this way is just to show the reaction in a proper way, convenient way. That's it. So this is one ethyne molecule, second ethyne molecule, third ethyne molecule. So these three ethyne molecule, I am passing it through red hot iron tube. Red hot iron tube. So now when I pass it to red hot iron tube, what will happen? Polymerization takes place. That means, this one of the pi bond will try to make a bond with this carbon. Here, one of the pi bond here makes a bond with this carbon. One of the pi bond here makes a bond with this carbon. So what is the product you will get? CH, and here pi bond made a bond with the next carbon. That means here you have only a double bond, CH. So a new bond will form between this carbon and this carbon, that is CH. And again here pi bond has gone for attack with the next carbon, right? So here you have only double bond, so CH, right? And a new bond with the next carbon, CH. So again a double bond, a new bond like this. So what is this? It is nothing but C6H6, which is nothing but benzene. Benzene you will get. Okay, so by polymerization of acetylene or ethyne, when you pass three molecules of ethyne through red hot iron tube, you will get an aromatic compound called benzene. This is also the most important reaction. Okay, so among all the chemical properties, the important chemical properties are acidic nature, addition of water, and cyclic polymerization of alkyne. Okay, so that's all about alkynes. It's a very simple topic. Okay, so most of the concept is similar to alkenes. If you know about alkenes, it's like you will understand very easily about alkynes. Nothing much to discuss about this. Okay, so hope the video has helped you in understanding the concepts well. If so, post your opinion in the comment section. Don't forget to post your opinion, because that means a lot. That gives us motivation to do more and more videos next. Okay guys, so I will come up with aromatic hydrocarbons in my next video. Thank you so much. Do subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you. All the best. See you all in the next video.